Hi guys, good afternoon. My name is Kyle from Group 2 and I will be reporting all about the physical design in computer system. So let's go ahead and define what physical design is. So in my PowerPoint presentation, it says here that this is the process of turning logical design into tangible. This involves determining on certain hardware and software components, designing technical system layouts and diagrams, and specifying the requirements placed on each components. Testing and prototyping are frequently part of physical design in order to make sure that the system will work as intended. So it says here that physical design is a stage wherein we are transforming logical design into concrete or a physical system. This just like what's being mentioned here, it is also involves determining a specific hardware and software components for us to be able to design technical system layouts and diagrams. It is also important as well in order for us to make sure that the system will work as efficient or as intended. Okay, so the physical design is a graphical representation of a system. It also shows the system's internal and external entities, and also the flows of data into and through out of these entities. So there are two types, or there are two entities for this physical design. So first is the internal entity. So internal entity is an entity within the system that transforms data. So this is, for example, the accounting clerks, departments, and computer things. So this is the entity within the system that transforms the data. Whereas in external entity, it is the entity outside the system that transforms the data. So when we say internal, it is within the system, and external is outside the system. So we can actually process as well, or do the logic of output and input for this physical design. It actually relates on that. This is laid down in terms of how data is given as an input into the system, and how it is being authenticated, how it is being processed, or how it is being displayed as output. So we can say that the physical portion of system design can generally be broken down into three sub-tasks. So that's gonna be the user interface design, data design, and process design. So for the user interface design, it is concerning with how user add information to the system, and with how the system presents information back to them. So para ka lang nagsa-search dito, like nag-search ka sa Google, and then the system will present information back to you. So dito pinapakita how the system is user-friendly and easy to navigate, which can greatly enhance our overall usability. So next is the data design. This is concerning of how the data is represented and is stored within the system. So data design is all about you saving data in the system or storing within the system. And lastly is the process design, which is concerning all about how data moves through the system, and with how or where it is validated, secured, and transformed as it flows into, through, and out of the system. So To use an analogy of this physical design, just like what I mentioned earlier, we can relate to the input and output base. Let's say, for example, a personal computer's physical design involves input via keyboard, and it will be processed will be within the CPU, and the output will be in the monitor or in the printer, and etc. It would not concern the actual layout of the tangible hardware, which for a PC would be a monitor, CPU, motherboard, hard drive, modems, video graphics, USB slot, and etc. It also involves a detailed design of a user and a product database, database structure processor, and control processor. Therefore, we can say that physical design specifies where, how, and whom a system process are accomplished. Also, a physical design does not tell us what is being accomplished.
Hello, good day everyone. So now we're going to tackle about physical design encompasses several key steps. So first one is floor planning. This involves determining the placement of various functional blocks and components on the chip's surface. It considers factors such as size and shape of the chip, the location of input-output pads, and the placement of power and ground connections. So, dito sa floor planning, para siyang blueprint ng isang bahay, like sa architecture, pero instead na furniture and rooms yung blueprint, magiging components siya ng computer chips. Example, yung processor tsaka yung memory. Para mag-work sila, yung performance space, syempre dapat naka-floor plan, tapos magiging maganda yung smooth or yung takbo kasi magtutugma kasi fit talaga silang lahat. Next is placement. Once the floor plan is established, the individual components such as logic gates, memory cells, and other building blocks are placed within the chip area according to timing, power, and area constraints. Dito naman sa placement, ayun yung positioning of components ng circuit board para mas bumuti or umayos yung performance tsaka connectivity. Hinahanap mo yung best spot para sa kanya para magawa mo yung purpose niya. Next is routing. After the placement, the interconnection between the components must be established. Routing involves determining the paths that signals will take to travel between different parts of the circuit while adhering to design constraints such as signal timing, signal integrity, and minimizing signal delays. So, dito sa routing, hinahanap mo yung best path or direction from one point to another. Dinadirect mo yung data packets or signal sa isang circuit para mapunta siya sa isang direction. Nai-ensure siya ng efficient tsaka reliable na communication between sa isang system or isang device. Tapos, dinidetermine niya yung most efficient paths para mag-travel yung data sa network. Next is clock tree synthesis. These steps involves the creation of a network of clock distribution lines that ensure synchronous operation of the different parts of the circuit. Dito naman sa clock tree synthesis, ito yung process ng digital circuit design para mag-create ng efficient tsaka reliable na distribution network para sa clock signals ng buong chip or electronic system. Yung clock tree, siya yung nag-i-spread ng main clock source sa iba't ibang bahagi ng electronic system. And yung goal niya is ma-ensure na lahat ng parts ay mabibigyan ng clock signals, sabay-sabay na clock signals. Nai-involve din siya sa designing tsaka optimizing ng paths ng buffers para ma-distribute yung clock signals ng iba't ibang parts ng circuits and marireceive mo siya at the same time and the right time. And lastly, the physical verification. Once the physical design is complete, the layout is subjected to various verification processes to ensure that it meets design rules, such as minimum spacing requirements, electromigration constraints, and other manufacturing-related criteria. Dito sa lab, yung physical verification, nag-i-involve siya na i-check yung layout or physical design ng isang semiconductor chip para rin ma-assure na mag-meet yung specification tsaka yung requirement set during the design phase. Then, mini-verify na to yung iba't ibang bahagi ng chip na kung tama ba yung pagkakalagay or nakakonect ba siya or may defects or errors na makaka-apekto sa functionality niya. Tumutulong rin bang ma-identify yung issue na nakikita or nagpapakita lang during manufacturing tsaka na-ensure niya rin yung final product na mag-meet ng quality and performance standards.